You're listening to the N2K Space Network.
It's been another record-breaking week in space, but for once, we're not talking about launches or SpaceX. We're talking about records being set by a human being for the longest total time spent in space. Can you imagine spending over 878 days in microgravity on board an orbiting lab that completes a rotation of the Earth every 90 minutes? No, me neither.
T-minus 20 seconds to LOS speed rest. Go for deploy.
Today is February 5th, 2024. I'm Maria Varmazis, and this is T-minus. A Russian cosmonaut breaks space day records. Geespace launches 7 new satellites into LEO. ISRO's humanoid robot will be launched later this year. And our guest today is Richard McCammon, CEO of C6 Launch Systems. He'll be chatting to Alice about why he's launching from Brazil and not from his native Canada. So stay with us for more on that in the second part of the show. On to today's Intel briefing. Russian cosmonaut Oleg Kononenko has set a world record for the total time spent in space. Roscosmos says at 8:30 GMT on Sunday, February 4th, Kononenko broke the record, surpassing his compatriot Gennady Padalka, who held the record at 878 days. Kononenko is expected to reach a total of 1,000 days in space on June 5th, but he won't be stopping there. By late September, when his mission is expected to come to an end, he will have clocked 1,110 days in space total. Wow. So, what did the cosmonaut have to say about reaching this milestone? Kononenko told Russian media this: "I am proud of all my achievements, but I am more proud that the record for the total duration of human stay in space is still held by a Russian cosmonaut." Now, this has us here at T-minus wondering if Kononenko has or is experiencing any long-term effects for being in microgravity for such a long time. NASA has shared studies in the past, most notably the study of identical twins with the Kelly brothers, although it's been a while since they updated that. Do we expect that Russia would share the study of long-term effects of microgravity on the body with the rest of the world? Well, who knows? But for now, we will join the celebrations and just exclaim, wow, human bodies are pretty darn amazing. Chinese car manufacturing company Geely Technology Group has made a bold move into the aerospace market over the last few years. It's a familiar tale to some of us here in the U.S. Its subsidiary, Geespace, conducted its second successful satellite launch over the weekend, sending 11 satellites into low Earth orbit. The company also announced that it has finished the deployment of the second orbital plane of the ambitious Geely Future Mobility constellation. This constellation is touted as the world's inaugural commercial initiative to integrate communication, navigation, and remote sensing within a single satellite network. The 9 satellites of the first orbital plane were successfully deployed in June 2022. So, Geespace has not only initiated mass production of satellites, but they've also accomplished orbital plane level deployment, achieving constellation level telemetry, tracking, and command. Maybe next they'll be producing the world's largest rocket. Put a pin in that one, huh? The Indian Space Research Organization is planning to send a robot to space ahead of its first human spaceflight. The humanoid robot is called Vyommitra and is expected to launch in the third quarter of this year. And Vyommitra is a name derived from 2 Sanskrit words, Vyoma meaning space and Mitra meaning friend. The robot will monitor module parameters, will issue alerts, and execute life support operations. The first crewed mission from India is scheduled for 2025. TechCrunch has released a story on a so-called stealth space startup working on harvesting resources on the moon. Interlude is the name of the company, and Interlude has reportedly raised $15.5 million in new funding and aims to close another $2 million. The company is being led by former Blue Origin employees. The CEO is Rob Meyerson, an aerospace executive and known angel investor. The CTO is former Blue Origin chief architect Gary Lai, who also flew on a New Shepard suborbital flight with the company. And over to the UK now, and we have two workforce development announcements. And the first comes from BAE Systems and the University of Portsmouth, who have launched the UK's first ever degree apprenticeship in space systems engineering. The executive dean for the Faculty of Technology at the University of Portsmouth said of the announcement that, in the midst of the UK's expansion and ambition within the space sector, addressing the critical challenge of a skills shortage is paramount to realizing our national aspirations. Applications are now open for the first intake of space degree apprentices who will be part of projects such as BAE's Azalea, which is due to launch its first multi-sensor low Earth orbit satellite cluster in 2025 to deliver intelligence in real time to military customers. And the second announcement from the UK comes from the University of Leicester and the National Nuclear Laboratory, known as NNL, who have established a strategic collaboration between their two organizations. The partnership will bring pioneering work in nuclear power to the university's education and research mission. NNL is the UK's national laboratory for nuclear fission and is working with academics and industry partners to develop spacecraft systems for the European Space Agency that provide reliable, long-lived power for harsh environments. It's hoped that the collaboration will play a vital role in the UK's ability to deliver the next wave of space-related nuclear power technologies, as well as supporting advances in transformative health and nuclear-related medicine. The European Space Agency has released a request for proposals that explore the potential for satellite-based nighttime datasets. The Dark Side of the Earth funding opportunity is seeking the development of new downstream applications that exploit existing and/or upcoming space assets during nighttime, mainly through the use of visible and infrared datasets. The applications will be used in sectors such as maritime, environment, smart cities, and more. If you're interested, more details can be found by following the link in our show notes. Egypt has launched an experimental satellite called Nexstar-1. The spacecraft was launched on a rocket off the coast of Yangjiang City in China's Guangdong province. The initial signals from the first test satellite were successfully received at the headquarters of the Egyptian Space Agency. This mission is part of the Egyptian National Space Program for the development of satellite technology. It's the African nation's first experimental satellite for remote sensing and was developed in cooperation with the German company BST. The Egyptian Space Agency developed the critical operating software and systems, as well as the functional tests of satellite systems and the subsequent integration, assembly, and testing procedures by a team of more than 60 engineers. And you'd have to be living in a groundhog hole to not know that Taylor Swift is dominating the universe right now. And yes, she has seeped into the space world. Sorry, and/or you're welcome. No, she isn't planning a trip to space that we know of. But she is now being used as a unit of measurement for asteroids. Yes, the folks at the Jerusalem Post are at it again. And yes, an asteroid the size of 8 Taylor Swifts will be passing by the Earth tomorrow. If you've got kids of a certain age, or if you are of a certain age, then I'm pretty sure you'll be familiar with some of Taylor Swift's back catalog. Anyway, we suggest following the link in our show notes for the Jerusalem Post article on this matter, and apparently it'll have you seeing red. And that concludes our briefing for today. As always, you'll find links to further reading on all the stories we mentioned in our show notes. And we also like to include a few stories that we didn't have time to cover today. And one of them that we have today is an opinion piece on why we need cybersecurity in space. Duh, we've been banging that drum for a while. And there's a link to the Explorers Club EC50 class and a piece from our friends at Druva Space. And there's also one from Orbital Fab's CEO on satellites losing billions of dollars in value. All those links and more are under selected reading and also can be found at space.n2k.com. Hey T-Minus crew, every Monday we produce a written intelligence roundup for you, and it is called Signals and Space. So if you happen to miss any T-Minus episodes, This strategic intelligence product will get you up to speed in the fastest way possible. It's all signal, no noise. You can sign up for Signals in Space to land in your email inbox over in our show notes, or, as always, at space.n2k.com.
The start of the year is a great time to take that next step in your education, career, and beyond. Rely on N2K certification prep to provide the tools to help boost knowledge, skills, and confidence to get you there. And now, for a limited time, all N2K certification practice tests are 40% off. Visit n2k.com/certify and use promo code N2KVDAY. That's N2KVDAY to save 40% on your purchase. That's n2k.com/certify with promo code N2KVDAY. Offer ends Monday, February 19th. Happy learning.
Our guest today is Richard McCammon, CEO of C6 Launch Systems. Our producer, Alice Carruth, spoke to Richard and started by asking him to just tell us more about his company.
C6 Launch is primarily a launch company for small satellites. So the differentiation we have is that we're launching small satellites, typically under 100 kilograms, to low Earth orbit, but we're doing it using a specialized vehicle. So we're doing it on a responsive basis, dedicated as well, so that people get what they want. The customer is focused exclusively with us, so that we can achieve what they want to accomplish by getting to space, rather than trying to get onto a ride share where the primary payload, the one that's probably a ton or more, is what's really dictating what the launch is capable of doing. So that means the orbit, the vehicles, or like the satellite dimensions, the launch time and the launch schedule. Those are huge, because that can take 2 and 3 years upwards to actually get a window that is even close to what the secondary payload wants. With us, it's a dedicated responsive ride. They're telling us when they want to go. They want to tell us where they want to go, and we're providing that launch service for them.
So when our paths crossed a few years ago, we were looking at you mating your vehicle with an Ursa Major Hadley engine down in New Mexico, and you were getting ready to start launching. What has happened since then? You've had a lot of issues, I know, that you've come into with regulations. I'd love you to talk us through it.
Yeah, regulations are a huge part of it, aren't they? So the reason we went down to Spaceport America was, one, the fantastic people we had to deal with, and certainly the support that we got all the way through from beginning to end was absolutely amazing. But the other was, as a Canadian company using an American engine, which is considered to be under MTCR, so that's the Missile Control Technology Regime, and it's a Category 1, which means that Canadians can't work on it. It's illegal for us to actually have anything to do with that engine and any of its specifications. So we had to bring on a secondary company in the US, and then hire individuals down in the States to actually handle the engine itself. The Canadian team was down there to handle all the other bits and pieces, so all the communications, all the control systems, the fluid dynamics, everything else. But when it came to the engine, we couldn't do anything on it. And the other side of it is we couldn't bring that engine into Canada because we don't have a technology safeguards agreement. Brazil, which we'll talk about a little bit later, United Kingdom, and New Zealand, and I think soon Australia, will have a technology safeguards agreement, which allows, again, Americans to work on the technology, but they can work on it in those countries. Canada doesn't have one, and it doesn't seem likely that we're going to get one soon. So we couldn't even bring that engine into Canada and fire it here. We had to go down to Spaceport America to actually do that work. One of the great things that it did for us was it taught us how to work within the boundaries of MTCR and ITAR, the international trades in arms reduction. And so we learned how to work within those regulations. We certainly didn't break any of them. We certainly followed all of the rules under the Technology Safeguards Agreement, or the TSA. So that puts us in really good stead when we want to move down into launching from Brazil or from the Shetland Islands.
And you also had regulation issues in Canada, because I believe you were originally planning to launch from Canada. What's been the hold up there?
There have been a number of them. We were looking at using maritime launch services out in Nova Scotia. So we had some discussions with them back and forth. They were slow, primarily because of environmental regulations. Also, getting some of the agreements locally for the construction and everything else. Maritime launch is they started construction early on. They actually had a small rocket flight. I mean, it's a student rocket flight there just last year. So they are making some progress there. So that was one of the ones, is that we don't have a launch site here in Canada anywhere other than MLS, and they're not ready for launch either. The other, as I said, bringing the engines into Canada, we can't. So anything we wanted to do in Canada that was completely outside of the legal framework that we'd have to deal with.
So tell us about that workaround you've come up with. I feel like this is building into this really great story. I didn't mean to interrupt you, but it sounds like you figured it out, which is really exciting.
We did figure it out. So we didn't rely on the Canadian government. Global Affairs is not making any. It's got no traction for getting the TSA in place, Transport Canada the same way. The Canadian regulations don't support space launch. The United Kingdom has gone out and written the Space Act and followed up with regulations on that. Canada hasn't even started that process. So we had a lot of regulatory as well as just nightmares as far as construction goes and things like that here in Canada. We had a real opportunity down at the IAC in Washington when that was held, and we met a number of people from the Brazilian Space Agency. Part of that spinoff was, we got a fantastic chief operating officer in Brazil, Paulo Vasconcelos, a former major general with the Air Force, and did a stint at the Brazilian Space Agency before joining us. We were really lucky to get him on board. He helped shepherd us through a public call and, more importantly, the contracting. So when we made application to the public call for access to the Alcântara Space Center in northeastern Brazil, we went after a sort of the mid-ground launch site. There were 4 aspects to the public call. One was for the rail launch, really small suborbital vehicles. The other was for what's called the wind profiler area, which we're now changing from wind profile radar base into a small launch pad for our vehicle. And the other was the larger TMI, which InnoSpace is now using. And the last one was the horizontal launch capability through the runway that's in Alcântara Air Force Base. That was given to Virgin Orbit, but unfortunately, they're no longer operational. We have this really unique spot in the world that has a technology safeguards agreement in place. So we can bring American equipment, particularly the Hadley, into Brazil, incorporate it into our vehicle, which will be built either in Brazil or Canada or the UK, depending where we source all of the technologies from. And Alcântara's got a huge infrastructure already in place. It is an operating space center. So we don't have to build buildings. We don't need to build white rooms. We don't need to put in generators and electricity and internet and water. And we don't need to do all of that. We've got that all in place because of the operational nature of the Alcântara Space Center. What we do need is we need to pour new concrete. We need to build the space pad out. We need to rejuvenate some of the electronics that are there, particularly with regards to control systems. But the bunker that we're going to use for the command and control center is right next door to us. It's about 500 meters away. And it is a bomb-proof building. And that's got full command and control. It's dedicated back to the Central Command for the Air Force. So all of this infrastructure is in place. We don't have to rebuild it.
What about the policies in place to be able to launch, though? Brazil, they're not known for a launch country. Have they got everything in place ready for you so you can go in and launch and get the licensing agreement set up?
Well, that's the beauty, is that we're dealing with the Air Force. There is no civil aviation. So all of the licensing that we need as far as launch capabilities are either through the Air Force or for the Brazilian Space Agency. And we already have our operator's license through the Brazilian Space Agency. We will need to make application, and we're starting that process now for the actual launch licenses with regards to the vehicle. But we're looking at that being probably a 6-month process in the beginning. But as we get through more and more of it and it becomes more cookie cutter, then I think we'll be able to cut that down to that responsive ride that we're looking for. Our goal is to launch 24 times a year from Alcantara, which gives us that really dedicated responsive ride that we keep touting about. And think of the things that are happening right now in the world. People need to get satellites up. Some of the things that are happening over in the Middle East and in the Ukraine and things like that, where people need to get satellites up and into place. But even things that are happening throughout the world that aren't as obvious, but some of the security issues that happen anywhere, some of the illegal fishing that's happening, some of the illegal practices that are happening. It's a lot better to get these small satellites into play today rather than 2 years from now, because that's just 2 years of lost opportunity.
We'll be right back. Welcome back. If you've been following research sent to the ISS for a while, I'm sure you've heard quite a few times about cancer research happening in space. But maybe it's just me, who knows? But I wasn't really sure I understood what that entailed. What's special about space that makes cancer research particularly effective there? Space is stressful on organisms like us. We talked about it at the top of the show. We've seen detrimental health effects on astronauts who've been on orbit for some time, lasting beyond even when they've returned to Earth. Is it just the cosmic radiation bombarding us without our gently shielding atmosphere that causes these changes? Well, you might think that, like how astronaut Scott Kelly had a number of genetic changes that happened to him from his time in space. His gut microbiome was changed. Even the tips of his chromosomes, called telomeres, were shortened. And that is a known health risk tied to health problems, including cancer and heart disease. But no, it's not just the radiation that has a detrimental effect on living things. As we hinted again at the top of the show, microgravity, like what's going on in low Earth orbit labs like the ISS, is really stressful for cells. And for cancer research, that's actually a really helpful thing, because that high stress of microgravity causes highly accelerated aging in cells. So if you want to test and see if a cancer treatment will work, if it will inhibit cancerous cell growth, putting that research into microgravity is sort of like pressing a fast-forward button on time. You send control samples and test samples up to space, and then space microgravity acts like that fast-forward button. And when you study the samples, you find out pretty quickly whether or not the cancer responds to your new treatment or not. And that's exactly what went up to the International Space Station last month on the Axiom 3 spaceflight, by the way. Mini cancer tumors prepared by a research team at the University of California, San Diego. And a data point here from them, cancer tumors previously sent by this research team to space have been observed to triple in size in microgravity in just 10 days. So during the AX-3 mission, this team, with their astronaut assistants, tested out a new anti-cancer drug that tries to block the gene that causes cancer cells to clone themselves. And with the accelerated space-time, they could see some very promising results for this new drug. So much so that they're hoping it may be a kill switch for cancer. Their words, not mine. So here's hoping. Thanks to the work of researchers on orbit and on Earth, we are seeing new advancements in cancer treatments every day. That's it for T-Minus for February 5th, 2024. For additional resources from today's report, check out our show notes at space.n2k.com. As always, we'd love to know what you think of this podcast. You can email us at space@n2k.com or submit the survey in our show notes. Your feedback ensures that we deliver the information that keeps you a step ahead in the rapidly changing space industry. We're privileged that N2K and podcasts like T-Minus are part of the daily routine of many of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. N2K Strategic Workforce Intelligence optimizes the value of your biggest investment, your people. We make you smarter about your team while making your team smarter. Learn more at n2k.com. This episode was produced by Alice Carruth, mixing by Elliot Peltzman and Trey Hester, with original music and sound design by Elliot Peltzman. Our executive producer is Jen Iben. Our VP is Brandon Karp. And I'm Maria Varmazis. Thanks for listening. We'll see you tomorrow.
T-minus.